welcome guys, and today we'll be learning about quadratic equations and inequations. So stay along, we'll learn a lot about what a quadratic equation means, ways of solving quadratic equation, and how does a quadratic equation look graphically. On the graph we would know some interesting methods of solving the quadratic equations, and that would be a lot of fun altogether. So let us get started. So what does quadratic equation mean? A quadratic equation is a polynomial equation. So now polynomial, the word polynomial suggests an equation that has multiple powers of a particular variable. Like we can say the equation x to the power 5 plus 1 equal to 0 is a polynomial equation. And another thing we can understand is that the quadratic equation is an equation that is of second degree. The word second degree is very important, as we'll see that this equation now is a quadratic equation. And how can we understand that it is second degree? The equation second degree is the variable has power 2. Power is the highest degree. The degree is the highest power, so we can say 2. We can see here x to the power 0, then here x to the power 1, then here it is x square. So x is a variable term and a comma b belong to real numbers where a is not equal to 0. Then the above equation is a quadratic equation as x has the higher degree of 2. So now let us get ahead. So there are various methods of solving a quadratic equation. So the first method is by factorization. Now how does this method actually work out? Some of you might have known this method in lower classes like 8th, 9th or 10th standard, but still I'll explain it up quickly. So we have a quadratic equation x square minus 5x plus 6 equal to 0. So now here we see this constant term and we find two factors. So now let us factorize 6 first. So 6 is 3 2s and 2 1s. So 3 and 2 we write it like this. 6 has two factors, 3 and 2, and now the sum of these factors, listen carefully, must be equal to this term. So for it to be equal, we need to make an equation. So we want this to ones. So minus 3 into minus 2 is equal to plus 6, and minus 3 plus of minus 2 is minus 5. So now we have got our factors right. This means, and so now we write those down. X square minus 3x minus 2x plus 6 equal to 0. Now we break this equation into two parts. This is first and this is second. And now in this we can see x comes common out of this both. Here we have second power of x and here it is 1. So we take x as common, x minus 3, and then out of this we want to make this term come once again over here. So if I took x as common, then what remains inside is minus x plus minus 2x plus 6, but we want this term. So what we do, we take the 2 common, so it is now 2. So what remains inside is minus x plus 3, but again the sign is inverted, so we take a minus as common, and now we get our factors right. x minus 3 equal to 0. So now we have done it correct. Oh, sorry, we don't take x as common as it is not there in both the equations. So minus 2, so x minus 3 into x minus 2 equal to 0. So now we can see x minus 3 is over here and x minus 3 is over here. So we take it common from the equation. So what remains inside is x minus 3 into x minus 2 is 0. So for a product of two numbers to be equal to 0, either one of the two must be equal to 0. So it is like x minus 3 equal to 0 or x minus 2 equal to 0. So x is equal to 3 or x is equal to 2. These are the roots of a quadratic equation. Now, you might be asking a question that what basically are the roots? Right? So what roots are, I'll tell you. Roots are those values of the variable, in here it is x, for which the equation is equal to 0. So that's why we write equal to 0. And over here, for the equation to be equal to 0, if we put this value 3 inside over here, this equation for sure is equal to 0. You try that at home and then you will realize that yes. So it is values at which equation is equal to 0. Or we can also write this as function is equal to 0. This is for the higher terms, we can express it as function is equal to 0. So what does this represent graphically to say? For a particular value to be equal to 0, this means for a particular equation to be equal to 0, this means that the above equation cuts the x-axis. So if we see it like that on the graph, I'll just show in a second, just a minute. So now let us continue further where we were. So I was going to show you that the equation cuts the x-axis. So f of x is y, so y is equal to 0. And on graph, what does y equal to 0 line represent? It represents the x-axis. So we are showing the points at which the graph is cutting the x-axis. So let me show it to you real quick. This is our graph and this is x-axis and this is y-axis. Let us assume that this is our graph. Just a minute. That this is our graph of an equation and let this equation be ax square plus bx plus c equal to f of x. This is f of x is just a general representation of a function and we are assuming this function. So now what does the roots show? The roots show these points. The roots show, let me highlight it with another pen. The roots show this point. We'll assume them as alpha and beta, as a and b are over here used. So alpha and beta are the points at which the graph is cutting the x-axis. You can see over here. I'll zoom it. It isn't zooming. Okay, anyway. The graph is cutting the x-axis of these points. So now for our equation, let us write our equation x square minus 5x plus 6. So I'll need to take my y-axis out for this. So this line I will need to remove it, because if you see, the roots are positive, and yeah, I'll show it in a minute what I was going to do. So this is our line, and this is a y-axis again, and these are the roots that are 2 and 3 for our equation x square minus 5x plus 6 equal to f of x. So at this point our equation is becoming equal to 0 at 2, 3. So these points are the roots, and now as they are positive, I had drawn the y-axis over here, which was completely wrong, so I corrected it. So now let us move further to our second method, and that is formula. This is the most important method that you need to remember in quadratic. If you ever have any quadratic equation, let us generalize it. If you have any quadratic equation ax square plus bx plus c equal to 0, then the roots of the equation, this is the root can be found by minus b plus minus under root of b square minus 4ac upon 2a. This is a direct formula which you need to learn. You actually need to learn this formula by heart, just as I have, as it is very helpful for other equations. And this term right here, which we see, this b square minus 4ac, is called as determinant. And now why is it called the determinant again? That's the question. So this term determines whether the roots are, number 1, real, number 2, irrational, I should say and imaginary, and even the perfect square. So now let us understand more about the delta. Let us understand about the determinant. So if the value of the determinant is greater than 0, that indicates that roots are real. And if the value of the determinant is a perfect square, then roots are integers. I should correct it over here. The roots are integers. Yes. Number second comes, if the value of the determinant is equal to 0, that means it has a common real root. Sorry for my handwriting. And if the roots are less, if the value of delta is less than 0, this indicates that roots are not real. Well, that is very obvious, as if we see over here, this value becomes less than 0, then the root cannot be less than 0, so it becomes a complex number, and then the roots are complex then. For those who are still below or in 10th won't understand this, but the students who are in 11th or higher 11th or 12th standard or higher standards would know what this means, not real roots. Okay, so let's go further. The roots are complex and we deal with imaginary numbers. I is root of -1, iota complex numbers as we say them. So now the third method is the Kramer's rule, which we do not have to study as it is a very lengthy procedure. If you want to know more about it, then you can Google it. It is a very easy method. I mean to say that it is easy, all the methods are easy, but this is a comparatively lengthy method for solving the quadratic, and you might have learnt it in lower standards of 10th or 9th standard. So let us move further. Let us understand the graphical importance of quadratic. So let me first draw a graph, a simple general equation again. Here and here. So okay, this is our x-axis and this is our y-axis, and let this be a quadratic equation, a simple quadratic graph. So just a minute, hang on. Let this be a graph and let the equation be ax square plus bx plus c is equals to f of x. So now how does it determine? So just a minute, let me copy this complete thing. Okay, it's not getting copied. Okay, so just a minute again, you to draw this graph because it is required at a certain point. This is x-axis and this is the y-axis. Oh boy. Okay, so this is x-axis and this is the y-axis, and the curve can also go this way. So now how will we determine whether the curve is this way and this way? With the help of our equation ax square plus bx plus c equal to f of x. Here also the same, ax square plus bx plus c. So now this all depends upon this first term, that is a. If a is greater than 0, then the quadratic is upward facing, and if a is less than 0, then it is downward facing. And now how will we determine? This is upon the opening, and we can verify this very easily. If we put in negative infinity into it, then the term becomes positive. So over here it is positive at negative infinity, and here at infinity is positive. So again the graph goes upward, and so it is like it. And if a is less than 0, so the term would be minus some constant k with a square, like sorry x square minus k times x square, and if we put negative infinity in, so at x equal to negative infinity, the term would be negative, so graph would be over here. And again, if we put positive infinity, still the graph would go down. So the points are like this. And this, what does this c represent then? It represents, I shall write it here, c represents the y-intercept made by the quadratic. So what is the y-intercept now? So this length is the y-intercept, and this length is the y-intercept. So over here in this graph, the y-intercept is negative. It is less than 0, y-intercept. So c is less than 0. Let me write it in blue. C is less than 0, and over here it is positive, so c is greater than 0. And what happens when we saw this, that d is greater than 0? So the equation looks like this. These both the equations represent when there are two distinct roots. I shall write that too. Distinct roots. Here also roots can be distinct. No, sorry, they are distinct. As if the roots aren't distinct, then yes. In this both cases, the roots are distinct, while over here the roots are common. So where were we? So now how does the graph of a common root look like? So we'll see that too now. So let me draw the axes. And this is our x-axis, this is the y-axis, and let us draw the graph. So if a is greater than 0 and c is greater than 0, then the graph would go somewhat like this. Touch the x-axis and go up. Let me take this graph and touch it at a point. Yes. So now as we see over here, only one point it is where the graph is touching, and it is alpha, or we can name it as beta, something, one of the two. It is the same thing. If let us name it as alpha. So at point alpha, alpha equal to x, y is 0, that is f of x is equal to 0. So in this case, let us now identify the y-intercept is positive, so c is greater than 0, and the graph is upward facing, that also means a is greater than 0. And the graph can go downwards as well. I shall show it to you now, like this. So I'll again take this graph and I'll put it at a point 1. See now, in this case, if you see this c, this part, c is less than 0. At the same time, a is also less than 0, and delta is equal to 0. So, and at the same point, at the same time, the graph can go somewhat like this too. This graph could be here or here, not somewhere else. So now let us see how does the graph look for when d is less than 0. So this is our coordinate axis, and yeah, finally all the arrows are drawn. And now when d is less than 0, the graph can go like this, like this, like this, and even like this. So all these cases are the same, where the d is less than 0, over here the same, over here the same, over here the same. But the difference is in the x and y, so in the a and c, that is the constants. So in this case, you shall say with me, a is greater than 0 and the y-intercept it will cut somewhere above, over here, from here above. So c must also be greater than 0 here. In this case, e is less than 0. At the same time, c is also less than 0. Over here we can see directly that c is less than 0, at the same time a is less than 0. Over here also a is greater than 0 and c, oh sorry. Here also we can see that a is less than, a is greater than 0. Yes, I written it correctly, sorry. A is greater than 0 and c is also greater than 0. The same here. This same. And the common condition for all these four graphs is that d is less than 0. This is very important to know how does a graph of quadratic look upon the changing of those constants a and c. It all majorly depends upon these two. So now let us come to the next part of quadratic, that is location of roots. What does location of roots mean? So this means that let us draw the coordinate axis. This is our coordinate axis. This is x, this is y. And now if I draw a quadratic equation on graph, so now the location of root shows whether this graph lies on this side of the coordinate axis, sorry for that, whether this graph lies on this side of the coordinate axis or it lies on this side, or it is somewhat inverted like this, downward facing over here, or over here it is there, or it lies somewhere over here. And now how can we know where does a graph lie? We cannot predict this actually. So this will be provided in our questions, that a specific quadratic equation has term. So let us write a quadratic equation on this, that is general equation ax square plus bx plus c is f of x, and both the roots. Now let us cover three cases for location of roots. Number one, lie on right slash left of a constant k, lie on either side of k. Yes, first we'll cover this two, yes, not three. I teach right and left differently, but they are the same cases. So now let us draw the graph. Everybody draw with me. This is our equations graph. This is x-axis and this is y-axis. Always write these things. They are very important to name the axes and all. So let us draw a general quadratic equation. And now it is said that both the roots lie on right. First let us say they lie on right of k. So this is point k and this is alpha and this is beta. So equation lies on the right of k. So for that we can say that if we see the function at k, it is upward facing. Now this all depends upon our constants a and c, or all depends on a majorly. As if a is greater than 0, then the quadratic will look like this, as it is shown over here, this. And if it is less than 0, then the quadratic would look something like this. So these are the two cases. We'll cover the first one, where two subcases. A, the first subcase is a is greater than 0, and the second subcase is a is less than 0. So the first case, a is greater than 0. So f of k as we see the output of function at this point is somewhat positive, is greater than 0. And something to note about this constants that I should have said earlier over here, the all over here. I'll so what does this equation show us is that the sum of the roots alpha plus beta is equal to minus b by a, and product of roots alpha into beta is c by a. So you need to remember these two. This is just like a general information that is always used in the questions. Yeah. So remember these two things, as we may need them right now in the concept of location of roots. So just a minute. If you have noted that down, yes, we shall proceed further. So we can say the sum of the roots over here, it must be greater than k. So we can say alpha plus beta must be greater than k, or in a general sense we can say it is greater than 0 if the y-intercept is also positive. That means c is greater than 0 and k is a positive number. If you understand, like, let k be equal to 2 and this is 3 and this is 5. So 5 plus 3 is 8, and 8 is always greater than 0. If we see, like, even if we don't know these two roots, and if it is said that they are on the right side, so on the right side, that means that it is for sure that alpha plus beta will be greater than 0 if k is greater than 0. So that's there. And then alpha into beta will also be greater than 0 if k is greater than. So the same condition applies over here. And but the basic definition, or basic thing we apply is this one, and d is greater than or equal to 0. If they have mentioned that the roots are distinct, then we do not write the equal to sign, we just keep this much. But they are mentioned, if they haven't mentioned about anything, then we take equal to 2. Always remember this one thing, it's all about inequality. So now let us see what happens when both the roots are on the left side of a particular constant. First, let us draw the coordinate axis. So this is x-axis, y-axis. Our basic graph for the explanation is this one now. I'll take this graph, which will clarify us a bit more, because generally people teach about this graph, but I'm taking a unique case so that we may remember it for a longer time. Okay, so now let this be alpha, let this be beta, and let this be a constant k. And now the equation is on the left side of k. As you see, the roots are on the left side of k. So what we first write is d is greater than equal to 0, as we don't know if they have mentioned or not, left side of k. And e is less than 0. Here we saw e is greater than 0. So if a is less than 0, x is less than 0, then d is greater than or equal to 0. This is the first case, as it is obvious. And the second thing, if we see f of k over here, it may go somewhere down and it meets. So f of k is less than 0. we see it from the graph. So plotting the graph of quadratic is very important. And now if we see over here, alpha is positive from this graph and beta is negative. So alpha into beta will be negative, as let us assume alpha is 2 and beta is minus 2. So 2 into minus 2 will give you minus 4. But there is a possibility that both the roots may be on this side, and it may be like, let alpha be over here be minus 3 and let this beta be equal to minus 7, and now alpha into beta will be greater than 0, as minus 7 into minus 3 is 21. So for this possibility, we do not take this condition. This condition is not valid. So I'll erase that. That was just for explanation. I took this case. So we put these two conditions on and we get answer. Now let us see a third case. Right side of k and e is less than 0. So we'll draw the graph real quick. That this is our graph. This is our x-axis, this is the y-axis, and now this is our graph, something like this, and this is our k. So now e is less than 0 as the graph is seeing downwards. I remember it that way. So now f of k is less than 0, and another condition is d is greater than equal to 0. But now again, if k is positive, then the first condition can be alpha beta is greater than 0 and alpha plus beta is also greater than 0 if k is positive. Now let us look at the fourth case, which is on left of k and a is greater than 0. So we'll draw the graph very quickly and no time to waste. So now this is x-axis, this is y-axis, and this is our graph. This is a graph of quadratic, and this is k, this is alpha, and this is beta. So now f of k would be positive, and d would be greater than equal to 0. F of k is positive, as we saw from the graph. And now I prefer not learning any of these conditions. I taught them so that you should have a rough idea about what is happening in quadratic. But there is no such thing to learn these conditions as something like if it is on the left of k. My basic theme is to draw the graph and then to proceed further. Now let us come to the second main case, that is lie on either side of k. So now for this we would need a nice graph. Yes, bigger one, yes. So now this is our x-axis and this is a y-axis, and now let us draw a graph. This is a nice quadratic graph, and this is a point k, and this is alpha. Let us assume that as alpha, and let us assume this as beta. So now over here again two cases come in when e is greater than 0 and e is less than 0. This is the graph when a is greater than 0. Yes. Now let us draw the graph for when, oh sorry, it is drawn, let it be drawn, we don't. Okay. Now let us draw the graph x-axis, y-axis, and now let this be like this. And now this is when a is less than 0. This is the condition over here we saw. And now I'm not considering c, we shall look that. And now over here f of k at k, the output of the function looks on the y-axis is negative. I'll take this thing over here for this case number 1, sub case A and sub case B. And if we see d is greater than or equal to 0, and over here if we see at point k, let us assume this is k, this is alpha and beta, f of k is positive and d is greater than or equal to, no, we can't say it is equal to 0 now. So if it would have been equal to 0, the graph would have not passed like this. So over here also I am removing equal to sign. So these are some of the things that we need to remember, like there is no equal to I'll write it both the sides. Okay, and by that we have covered our most of the part for quadratic. The only thing left is questions which you can solve from any other material book. And I have given a rough idea about what a quadratic is. So let us get quickly on what quadratic is now. So we have to see our constants a, b. I'll take another color pen, maybe this color. So now we have to see alpha, b and c. These three constants, first of all, condition should be a is not equal to 0, or else it won't be a quadratic. So it would be a first degree equation like bx plus c, which is a linear equation which we have studied in lower standards. And now methods of solving quadratic, the first is factorization method. The second is the formula method, in which we have to learn this formula minus b plus minus b square minus 4ac. This term is also known as delta. And now delta determinant determines our equation. And now if delta is greater than 0, then the roots are real. This is important. And then if the delta is a perfect square, then the roots are integers. This is also important. And then integers are positive as well as negative. And delta is equal to 0, there is a common root. Delta is less than 0, then the roots are not real. And then there's third method called Cramer's rule. And then we learnt about the sum of the roots and the product of the roots, which can be expressed as minus b by a and c by a. I would take this as very important, so I wrote it at the top, which we need. Now next we learnt on this about graphical representation of quadratic, that is graphical importance. So if a is greater than 0, then with me the graph is upward facing, and if a is less than 0, then the graph is downward facing. If c is greater than 0, then y-intercept is positive. If c is less than 0, y-intercept is negative. So now then we saw various examples where c is greater than 0 and a is greater than 0 and c is less than 0 and a is less than 0. So now let's go on to location of roots. In this, the basic theme is to draw a rough sketch of the graph. We won't be able to plot it exactly as a simulation or a computer would, but we draw a rough graph of a quadratic based on our constants a and c. And also we see the condition if it is on right or left side of k, or it is on either side of k. These are the main important conditions, and accordingly we solve our graphs like this, and that's it. With this we complete quadratic. There shall be some questions which I'll upload later, and the short notes will also be available. Thank you.